people, welcome to Night Out Notes. In previous video, we learned what is transaction. A transaction is simply a group of database operations performed as one unit, right? But when many transactions are come together, which operation should happen first and which should happen next, we don't know, right? To know that process, we use this scheduling. Scheduling is a process of deciding the order in which operation from multiple transactions are executed while maintaining data consistency and avoid conflicts. It is mainly used to decide which operation should be performed first and which should be performed next. Scheduling itself tells us which time it should be done. Which operation should be done at which time will be decided by this scheduling. In a simple example, we can say that a few people are waiting for submitting their assignments to their faculty. Many people will come and give their assignments immediately to the faculty. It may lead to the confusion, right? So individually, one single person will come at a time and give their assignment to the faculty. So the teacher understands who submitted which assignment to them. In the same way, DBMS decides in which order the transaction operation should execute. That decision-making process is called as scheduling. Scheduling is mainly divided into two types. The first one is serial scheduling. By the word itself, we'll understand that one by one will happen inside this serial scheduling, right? So one transaction completes before the next transaction starts, which means one transaction should end. After that only we can start one another transaction. Like see, here we are starting one transaction 1. It should be committed over here. After committing only we can start transaction 2. So after committing we can start transaction 3. So it is like after completion only we can go to another transaction, we can start another transaction. This is what the serial scheduling says us. See, in a general example, we can say that we are going to some hospital and waiting for doctor to meet us, right? Like the person who took the first appointment goes to the doctor first and consult him, and then the next appointed person, right? In the same way, serial scheduling works. Like advantages: simple and consistent. Serial scheduling is very easy to understand because only one transaction will happen at once, right? And since no transactions can run together, there is no chance of conflicting. So it will be consistent. Database remains correct. Since only one transaction is happening, after completion only another transaction is happening, right? So database remains consistent because only the latest updated data will be stored inside it. Disadvantages: it is slow because only single transaction is happening. Less resource utilization. The CPU and database resources are not fully used because when the one transaction is running, other resource remain idle, right? So less resource utilization. Poor performance because every transaction waits for the previous one to finish, right? So the overall system will be running slow and performs weak. Less throughput. Throughput is nothing but number of transactions is happening for given amount of time. Let's consider there will be 2 minutes of time. In 2 minutes of time, how many transactions are happening? Like the time varies and how much amount of transactions, how many transactions are happening at a specific amount of time is called as throughput. Here only so less amount of transactions are happening, right? So less throughput. Non-serial scheduling or parallel scheduling. This scheduling is an advanced enhancement of this serial scheduling. The word it says that parallel scheduling where multiple operations are simultaneously worked at a single time. Like see, depending upon the availability of operations, multiple transactions execute simultaneously. Like based upon how many CPU database resources are not fully done, like which are in idle state, based upon that it will go and it will execute the transaction simultaneously. Like see, here transaction 1 and transaction 2, transaction 3. 3 transactions are there here. Here we are reading transaction A along with transaction B, transaction 2, and writing transaction 3. These 3 operations are happening in a single time, right? So there will be no time gap and waiting for that. So see, transaction 1, before committing only another transaction will start. Like it's not committing here, like it's not ending. At before only the other thing will start its work. This is what non-serial scheduling or parallel scheduling says. Advantages: better performance because all those things are simultaneously worked, so the overall performance of the database will also get improved, right? High throughput, as I said, the throughput is nothing but the number of transactions happening in a single amount of time. Like there will be more transactions in a single time, right? So it will be high. And fast, because lot of transactions are happening simultaneously. Disadvantages: lost update problem. This happens when two transactions update the same data at the same time. The second update overrides the first update. As results, the update is lost. Like first update will be lost in that case. Next, inconsistent data. When multiple transactions interfere with each other, the database maybe temporarily stores those information but not permanently, which may lead to the inconsistent data. Complex. Managing many transactions together is not easy, right? Which leads to conflicts, control concurrency, removes of failure, and many issues are there. So non-serial scheduling is more complex than serial scheduling. Yeah, that's all about scheduling. Hope you like this video. Until then, don't forget to hit that bell icon and subscribe to my channel so that you'll get more informative videos like this. If you found this video really helpful, please like and share. Meet you in another video. Bye bye.